Assalamualaikum warahmatullahi wabarakatuh. Today I'll be presenting our IDP project on PICO-HYDRO power generation at Sungai Lembing, Pahang. So the group members are Ahmad, Afiq, Mustaqim, Megat, Alif, Fahmi, Nur Sazianty, Siti, Zuhairah and Tengku, Eliza. So the objectives of our product is to design an electrical and electronic system, hydropower electricity, and then we are going to design electricity supply for houses for their daily consumption. So we did a bit of a market research for hydropower energy. So the global market estimated a 13% increase by 2024. This is surrounding small hydropower mainly in Asia Pacific. So the Asia Pacific's hydropower market is increasing due to investors and demand for green energy. So the major players of the sector are India and Japan. Okay, the compound annual growth rate is expected to increase to 2% from 2020 to 2027. It can be attributed to factors such as financial investment, rural electrification generation, and policy. It is also the global response for climate change and demand for more environmentally friendly power generation. Okay, we did a SWOT analysis on our product. So basically the strength of our product is that it can run all day long. It is a run-of-a-river design, so that it does not require any storage tank, and it is also backed up with batteries. The weakness is that the cost depending on distance from water source, and it must consider voltage drop during transmission. But the opportunities for our product is that they are increasing interest in renewable energy and distributed generation. There is also the need to reduce dependency on national grid. And then we can also hybrid our product with other renewable energy such as solar. But the threat is that there are cheaper renewable energy such as solar which can be installed directly at our home. And then there's also the natural disaster such as flooding damage. Okay, I will now pass my presentation to Siti Zuhairah for the next part of this presentation. Thank you.
Our marketing plan, first product, our product capable of supplying a household with 500 watt. The system makes use free power source to provide end user with free electricity. The product includes a unique turbine design coupled with a generator placed on the river to transform the moving water potential. And then for the price, referring to the distance between water source to the house, cable size is directly proportional to the voltage drop and the price increases correspondingly. For this project, the estimated cost for the 40-meter distance is 3,062 ringgit and 90 cents. Our target audience specifically for residents in areas without access to the national grid. The area must also be equipped with a river that flows at rate of 4 meter cube to 6 meter cube per second all year long generally. And for promotion, advertisement of this product will be posted in the newspaper and online. For more intensive promotion, door-to-door advertisement might be needed, especially for rural area residents. This will also allow for our target audience to fully understand in depth of the product and how it will benefit them. The method of our project will begin with planning the system with our group member, and then draft the system design to realize the idea. And then we calculate all the requirements needed to operate the system. And then we simulate the projects using MATLAB software. And when the performance satisfied, we calculate the wiring and loads for distribution board. And we design the wiring for the house.
Assalamualaikum, my name is Megat. So for this project, we have made 6 assumptions, which is the water flow rate, around 4 to 6 meter cube per second. The losses between the transmission line, the distance between the generator to the house, which is 40 meter, the generator efficiency, which is around 85%, and the battery capacity that we have calculated, and also loads. For the design of the project, we plan to make an inlet channel from the river to make sure that the water is clean from the rubbish by putting a filter before the water goes into the inlet channel. And then we will put our product at the slope of the river, and the water will goes back into the river. So this is the project load that we have assumed inside one house. It is including the smartphone for charging, laptop, the lighting for the house, the fan, and also the refrigerator. And all this load makes up to 430 watts in one time. So this is the product of our hydro generator. We make the design such that it can be moved easily, so it is a very high mobility product. The water will goes into the bottom part of the product and will turn the turbine. This is our system process flow. We start from the river. The energy will be harvested from the river into our hydro turbine when we plan to use DC generator. The power from the generator will be stored into the battery, and to convert it into AC, we plan to use the inverter. The inverter will also boost the voltage from 24 to 230 and will be supplied to the house. Next, I will be pass my presentation to Afiq Mustaqim.
Hi, my name is Ahmad Afiq Mustaqim. For this simulation, we are using MATLAB software, Simulink. The first part of the system is DC generator. This is the DC generator, and this is the torque applied from the river, negative 4.5. And the parameter that we measure is current, voltage, armature current, field current, speed in RPM, and torque. The figure shown is the voltage and current generated by the DC generator. The current is 8.84 ampere, while the voltage is 88.4 voltage. Next part for the simulation is the batteries. Assuming this is the output from the generator being applied directly to the batteries for charging purpose, and the parameter that we measure is the output voltage, output current, and standard of charge of the batteries. The figure shown is the state of charge of the batteries, output current, and output voltage of the batteries. As you all can see, the state of charge of the batteries is slowly increasing, and the output current is 7.5 ampere, while the output voltage is 23.96 voltage. The next component in the simulation is inverter. Firstly, we use buck converter to boost the output voltage from the batteries, and then we convert it to AC by using inverter circuit. The figure shown is the output voltage waveform of the inverter. The output voltage is 232 volt, so it does fulfill the requirement for voltage supply in a single phase house. Next, I pass to Eliza.
Next, I will explain about the wiring design for the house loads. So this house consists of living room, kitchen, toilet, and 2 bedroom. So this is the power supplied from the distribution box. We use MCB of 16M and 6M. So the calculation and the loads determination is further explained in the report. So for the estimation cost, we use DC generator, inverter, 40 meters, 6 mm square wire, 2 battery, 12 volt, protective relay, and 1 model turbine, power generator controller. And the total cost is RM3,062.90. For the electricity bill cost, we assume it to be smartphone, laptop, kitchen lighting, living area lighting, bedroom, toilet, fan, and refrigerator. And the cost per month is RM35.28. So for the requirements for the system, first we need waterproof DC generator because generator is located in a river, so it must be water resistant to avoid any damage to the generator. And next we need a drainer as a filter to prevent rubbish and unwanted material from entering the turbine. Next, specific water level to ensure water flow. It is enough to generate power that exceeds the bare minimum of 500 watts. And then we need 2 units of battery storage, so it could be 1560 watt. So as for the protective relay, a relay device designed to trip a circuit breaker when a fault is detected. It can also be used to provide additional protections such as overheating and overvoltage. And next, there are several constraints that we face. First, water flow rate, because unstable flow rate depends on weather and flood. Next, initial cost funding is high due to the maintenance cost. Next, rubbish in the river can cause severe damage and malfunction to the turbine. Lastly, COVID-19 pandemic. During this pandemic, we are prevented from visiting the location to collect data. Instead, we find it through various reliable resources like journal and magazine. Lastly, for the conclusion, we are able to design an electricity generation to the remote area with 500 watt energy supply for daily consumption, and PICO-HYDRO water plant not only benefits for the people but also helps the earth and environment as a whole. Thank you. So for the further explanation, it is included in the report. That's all.